NCM Learning Center. Good morning friends. In this video, we are going to discuss about the losses and power flow concepts of induction machines. In the previous video, already we discussed the basics of induction machine at part 1 videos, and part 2 videos we discussed the problems from the relations between the frequency of rotor current with slip, and part 3 videos already we discussed the equivalent circuit of induction motor. In this video, that means part 4 videos, we are going to give the detailed discussion of losses and power flow concepts with problems. In this next video, we will discuss the remaining topics one by one. So let us discuss the losses and power flow concepts. We know that equivalent circuit of induction machines. Already we discussed. Just refer the part 1, part 2 and part 3 videos. That video link is attached in the description box of the video. If you know the equivalent circuit of induction machines, we can easily understand the losses and power flow concepts. By the equivalent circuit, we may write the power flow. When the stator input is given, there is some stator copper loss, stator hysteresis loss, eddy current loss. So the remaining power goes to the rotor side. That means rotor input. On the rotor side, there is a rotor copper loss, friction, windage losses. So the remaining losses is converted into a mechanical useful power developed. Okay, this is a power flow. This is another way of power flow representation. Let me represent Pin is a stator input, P2 is a rotor input, PM is a mechanical power developed, then PSCU stator copper loss, then it represents PE is the eddy current loss, then PRCU rotor copper loss, PS is total stator loss. Total stator loss means summation of all losses in the stator side. Stator copper loss, stator eddy current loss and hysteresis loss. Then PH is hysteresis loss, PF in the rotor side friction and windage loss. Then PR is a total rotor loss. Total rotor loss means summation of rotor copper loss and friction and windage loss. Okay. So from this power flow, we write P2 rotor input is a stator input minus of total stator loss. So P2 is equal to P minus PS. So PS means total stator loss means summation of all stator losses, stator copper loss, stator eddy current loss, hysteresis loss. Then mechanical power developed, PM is equal to rotor input minus total all rotor losses, PR. So total rotor loss PR is equal to summation of rotor copper loss, friction and windage losses. Okay. Next, we will discuss the relation between the rotor input and rotor copper loss. We know that power is equal to torque into angular speed. Rotor power input P2 is equal to torque into synchronous speed. NS input side, rotor input. So synchronous speed. Then rotor mechanical power developed. Mechanical side, useful power. Torque into rotor speed. So substitute this. Equation 4 and 5 in equation 3. We will get T 2 by NT PM value, P2 is equal to 2 by NS into T, total rotor loss PR. From this equation we can find the total rotor loss PR is equal to 2 by NS minus N into T. Let me take this equation as 6. Divide this equation 6 by 4, you will get PR by P2 is equal to NS minus N by NS, because T will be cancelled, 2 by 2 will be cancelled. We know that NS minus N by NS is equal to slip. So total rotor loss PR is equal to S into P2. This is important relations. Let me take this equation as 7. PF friction and windage loss value will be very small. So PF value approximately equal to 0. So now PRCUs, if friction loss value is equal to 0, total rotor loss very close to rotor copper loss. So PRCU is equal to S into P2. This is the relations between the rotor input and rotor copper loss. If friction loss value is given, first we have to find the total rotor loss. From that we can find the rotor copper loss with considering the friction windage losses values. Next we will discuss the relations between the rotor input and mechanical power developed. Substitute this equation 7 in equation 3, we will get PM value, PM is equal to P2 minus Instead of PR value, we substitute here S into P2. Simply with this equation, we will get PM is equal to P2 into 1 minus S. This is the relation between the rotor input and mechanical power developed. Now we will discuss problems. This question is asked in TRB 2017 examinations. Here, objective is to find the mechanical power developed, PM value. We know this relations. PM is equal to P2 into 1 minus S. We know the relations between the mechanical power developed and rotor input. So, what is only a P2? P2 is a rotor input. P2 is equal to input minus total stator losses. Here, given value Pn is equal to 40 kilowatt is given, input value is given. Here, stator resistance and core loss are negligible. So, PS value is equal to 0. So, we can find P2 value. P2 is equal to 40 kilowatt rotor input. Substitute here, mechanical power developed PM is equal to P2 40 into 1 minus slip is equal to 5%, 0.05. Simply this equation we will get the answer as 38 kilowatts. So option C is correct. So next, problem 2. This question is asked in TRB 2021 examinations. Objective is to find the rotor copper loss and mechanical power developed. We know these relations. Rotor input P2 is equal to Pin minus PS. Pin means stator input, PS is total stator loss. So Pin is given. Pin is 90 kilowatt. PS total stator loss is given 2 kilowatt. Substitute here. We will get 90 minus 2 is equal to 88 kilowatt. Rotor input is 88 kilowatt. We know the relations between rotor copper loss. Here friction loss is not given. Friction windage loss is not given. So friction windage loss will be considered as 0. So we know the relations between the rotor copper loss and rotor input. PRCU is equal to S into P2 because friction and windage loss will be considered as 0. So substitute these values P2 values and slip value. Slip value is 4% is given. Substitute here. So PRCU is equal to 0.04 into 88. We will get rotor copper loss value is 3.52. Here option D is correct. We will find the mechanical power developed also. PM is equal to P2 into 1 minus S. Here P2 value is 88 kilowatt. Substitute values 88 into 1 minus 0.04 will get 84.48 kilowatt. So option D is correct. Now for do it yourself. The first question is asked in GATE 2021 examination. The second question is asked in IES 2018 examinations. Solve these questions. My answer key is for the first question answer is 90%. For the second question option C is correct. If you have your mismatch your answers, then comment your answers. If you have any doubts related with this discussion, just post your doubts in our NCM Learning Center WhatsApp group. So you can get the clarification immediately. Continuously watch our channel. Definitely you can get the good marks in the combat examinations. Good. Thank you. Thanks for watching. Click the subscribe button and click the bell icon for notification. Like, comment and share.